Hello, greetings to everyone. We are the team AIXSense from RWTH Aachen University, Germany. I would like to start a sensor development for valve rate measurement with technological novelty. We are using metal organic framework or MOF for sensing valve rate. MOF is a solid crystalline structure with metallic centers bonded to organic linkers. Here MOF we have chosen is terbium based MOF. It is deposited over the gold interdigitated electrodes. The next one is our sensing strategy. The sensing strategy we are using is electrochemical impedance spectroscopy. It requires less equipment compared to other techniques and it can be made portable. This makes our electrical readout easier and also the sample volume we are using is very small. Our fabrication technique is simple and reliable and therefore we can manufacture this in large quantities. Then I'm moving to molecular recognition part. As I said already, MOF is deposited in gold interdigitated electrodes. MOF provides large surface area with considerably good mechanical and chemical stability. Due to the surface functionalization, measurements based on luminescence, field effect and impedance is possible. In our case, valve rate molecule size agrees with 4 dimension of MOF. Hence, valve rate can be identified by surface functionalization.
Physical transduction. Measurements are done using electrical impedance spectroscopy with a 3 electrode setup. Here, one of the finger pairs, the working electrode, is coated with MOF, while the other finger pair is left uncoated. The reference electrode is a commercial miniature AGCL reference electrode supplied through an inlet. Upon contact with the analyte, the impedance changes over time of the working electrode, which is registered at a specific frequency. To get reliable measurements, both the impedance after a specific time frame as well as the slope of the impedance change over time is considered. So through data statistics, a correlation between the amount of VPA and impedance change is achieved. The cartridge technology. Sensor consists of a 7x7mm dies with a PDMS microfluidic system on top of the chip. These dies are glued on a chip carrier and electrically connected with bonding wires, which are passivated using PDMS. The cartridge consists of these chips cameras, including the microfluidics system and the chips, and can be connected to the device by insertion into a chip socket. Reader instrument and user interaction. Readout of the impedance measurement is done by an MStat Pico, which is connected to the 16 IDU working electrodes via multiplexes, since the MStat Pico accounts only for a pair of electrodes. All channels share common counter and reference electrode, which are directly connected to the MStat Pico. The MStat Pico communication is read out with a microcontroller via UART, so the microcontroller can calculate the VP concentration using a calibration curve. The calculated concentration is communicated to the user using a display. Additionally, raw data and a log of results are stored in the integrated memory. A cartridge change can be easily done by the user by removing the cartridge from the spring-loaded socket and inserting the new cartridge. Our technological feasibility. The sensor uses a microscale gold interdigitated electrodes on a glass substrate fabricated using standard clean room lithography technological process. Therefore, fabrication is cheap, allowing mass production and very high reproducibility. These IDEs allow precise electrochemical impedance spectroscopy as well as functionalization of every single electrode separately as done here using metal organic framework to enhance the impedance readout. This allows different MOF layer characterization on a single chip. The electrochemical MOF deposition process has shown high reliability and reproducibility and good mechanical stability. Thus, as an overall matching criteria, AIXSense can produce a reliable and an efficient biosensor for valve rate measurement for the millions of people who need it.